All right, students, so today we're going to do 1.7c. So here we're going to be doing our lab on concentration, so concentration calculations. So we'll open this up. And so again, the first thing that I'm going to ask you to do is to translate these words here. Please translate these to your home language. You can write the word here in your home language. Then once you have translated those, here it tells you the direction. So using an electronic balance, measure out the following amounts of Kool-Aid and water to make a solution of Kool-Aid. Calculate the concentration using concentration equals mass of the solute divided by the volume of the solvent. So the first thing it's asking you here, so say, in this example, what is the solute and what is the solvent? So a solute, students, as a reminder, a solute is something that dissolves inside of water. A solvent is the liquid that dissolves the solute. So in this lab, the thing that we're going to be doing is we're going to be mixing, we're going to have some Kool-Aid and we're going to be mixing it inside with some water. So in this case, right, our solute is the Kool-Aid, right? This is the thing that's going to dissolve inside the water. And then the solvent is our water. This is the thing that is going to dissolve the Kool-Aid. So this is the solvent, this is the solute. All right. So when we write our answer, then we're going to write that our solute is the Kool-Aid, and our solvent is the water. Great. So what we're going to do is we're going to make three solutions, three cups. The first cup is going to have 10 grams of Kool-Aid. The second one will have 20, and the third one will have 30. Each cup is going to have 100 milliliters of water, and then we're going to calculate the concentration for each of these cups. So in order to do that, we're going to have to use an electronic balance. An electronic balance is a tool that we use in science to take the mass of something. So this is how we're going to do it. So if we look back here, so here we have our electronic balance. We can turn it on. First, what we're going to do, so we're going to find the mass of the Kool-Aid. So we're going to use this. So here we see that it's at 5. I'm going to click 0. So I want to add, for the first one, I want to add 10 grams of Kool-Aid powder to the cup. So let's find, we want to make sure that we get to 10. All right, so we have 10 grams here. So I'm going to put that into the one that is cup 1. So I'll put these 10 grams in for cup 1. Then I'm going to, and then the second one is going to have 20 grams. So let's see until we get to 20. There we go. So that's 20 grams. We'll put 20 grams in the second one. And then we'll put 30 grams in the last one. So here we have 30 grams in the third one. Then we're going to put 100 milliliters of water into each of these. So I have my little cup, and this first line is 50. The second one is 100. So I'm going to put 100 milliliters of water in all three of the cups. There's 100 once into this cup. 100 milliliters again. Second cup. And 100 milliliters into the third one. Put a little too much. Put some back. We have 100 into the third one. All right. I'm going to mix all three of them separately so that I can see the solutions. So this is cup 1. This is cup 2. And this is cup 3. All right. So now, so we can kind of see them visually, but what I want you to kind of think about here is, right, so what are we noticing is different here? So, right, I'm seeing that this cup, right, this cup here is darker, has a darker color than this cup here. This cup is the lightest. This one is in the middle. So we're going to answer these questions about this. So which one of these do you think is the sweetest? So let's answer these questions on the worksheet. So if we look back at our worksheet, here, right, we have our concentration. We can calculate our concentration now. Our concentration is calculated by the mass of the solute, so the mass of Kool-Aid, divided by the volume of the solvent, which is the water. So let's see, in this case, right, the solute we had was 10 grams, and we're going to divide by 100 milliliters. That's how we calculate concentration. Now, if we put this into a calculator, right, 10 divided by 100, we get that this is 0.1. So 0.1 is our concentration, and the units are 0.1 grams per milliliter. So 0.1 grams per milliliter is the concentration of the first one. In the second one, we're going to have 20 grams divided by 100 milliliters. So 20 divided by 100. And if we calculate this, right, 20 divided by 100, we get this is 0.2. And then for the third one, we have 30 grams divided by 100. And if I do 30 divided by 100, I get that this is 0.3. So let's put 0.3 here. Great. So first it's asking us to put the cups in order from the least to the most mass of Kool-Aid. So the cup that has the least amount of Kool-Aid is going to be cup 1, right? Cup 1 only has 10 grams. So first is cup 1. Then we have cup 2. Then we have cup 3. So cup 1 has the least and cup 3 has the most. So they're from least to most. Now it's asking us to put the cups in order from the least to most volume of water. So in this case, cup 1 has 100 milliliters of water, cup 2 has 100, and cup 3 has 100. They all have the same. So cup 1 is the same as cup 2, is the same as cup 3. All right. Now it's asking us to put them in order from least to most sweetness. So if you want to, you can actually taste these. So you can actually taste the juice. And what you see, right, is the more Kool-Aid there is in it, the sweeter it becomes. So it's going to become sweeter with more Kool-Aid, with more mass of Kool-Aid. So cup 1 is the one that is the least sweet, then cup 2, and then cup 3. All right. What I want you to think of, students, is that the sweetness and the concentration of something are the same thing. So if something is sweeter, that means it's more concentrated. So in the same way that cup 1 is the least sweet, cup 1 is also the least concentrated, right? So its concentration is 0.1. The second highest concentration is cup 2 with 0.2. Then the third highest is cup 3 with 0.3. So the most sweet one is cup 3. The least sweet is cup 1. Great. So now what we're going to do is we're going to answer this question. So how does increasing the mass of solute change the concentration of solution? So if I add more mass, if I add more Kool-Aid, increasing the mass of Kool-Aid causes the solution to do what? So if I add more Kool-Aid, right, if I compare these 3 cups, and again, I can look at them again, right? The one that has the most mass is this one, right? This is the one that is the darkest color. It's also the one that tastes the sweetest. And that means it's also the one that's the most concentrated. So all of those things mean the same thing. So what we'll say is increasing the mass of Kool-Aid causes the solution to get more concentrated, right? Which makes sense, right? If I add more sugar, it's more sweet or sweeter. So that helps us there. Let's then move on to this next one. Let's move on to this next question here. For this part, so yeah, again, the more mass that we have, the more Kool-Aid that we have, the more Kool-Aid powder that we have, the more sweet it's going to be, the more concentrated it is. So if we increase the mass, we're going to increase the concentration. Now we want to see, so how does changing the volume, what if we keep the mass the same? How does changing the volume change the concentration? So for this, we're going to need three new cups. For the first cup, we're going to put, in all 3 cups, we're going to put the same amount of mass. We're going to put 15 grams in each of these. But we're going to change the volume. The first one is going to have 50 milliliters. The second one will have 100, and the third one will have 150. So let's do that right now. So we'll need to have 3 new cups. Let's move these out of the way. We need 3 new cups. All right. We want them each to have 15 grams of Kool-Aid. So we'll turn this back on. We need 15 grams of Kool-Aid. So I want this to be at 0. So let's add 15 to each of these. All right. So that's 15 grams. I'm going to add 15 to the first one. Let's do it again. I put too much. Turn back. And it's 16, a little bit less. 15. All right, great. 15 into the second one, and then 15 into the third one. All three of them should have 15. And 15 into the third one. So all of them have 15. And then what we're going to change is we're going to change the volume. So the first one is only going to have 50 milliliters. So 50 milliliters is this first line here, and 100 is the second one. So let's add 50 milliliters to the first one. 50 for the first one. 100 for the second one. And then 150 for the third one. So we'll have to do 100, 100, and then 50 more. Now I have my 3 cups. And let's mix them up. Make sure they're well mixed. Okay. So you may be able to tell by the color, maybe not. But if you actually look at them, so right, this one is the one that is the most red. This one's a little less red, and then this one is the least red. So you might imagine, right? So they all have the same amount of sugar. They all have, or they all have the same amount of Kool-Aid, but they have different amounts of water. So if you actually taste them, this first one is very sweet. The second one is not as sweet. And the third one is the least sweet. It's definitely not sweet at all. So let's actually look at calculating these numbers. All right. So in the first one, right, we have 15 grams of sugar, and we're going to divide, or 15 grams of Kool-Aid, and we're going to divide by 50 milliliters. The second, so if I do this, if I have 15 and I divide by 50, I get that this is 0.3. So this concentration is 0.3 grams per milliliter. For the second one, we have 15 grams divided by 100. So if we do this, we're going to get 15 divided by 100, which is 0.15. And we have 15 divided by 150, which is 0.1. 15 divided by 15, by 150. All right. So first it wants us to put them in order from the lowest to highest mass of Kool-Aid. Well, all of them have the same amount of Kool-Aid. So all 3 cups have the same amount of Kool-Aid. So cup 1 is the same as cup 2, is the same as cup 3. What about the volume in terms of lowest to highest? So cup 1 has the least water. Then cup 2 has the second. And then cup 3 has the most water, has the highest volume of water. How about their sweetness? So which one is which of these is the sweetest? So the sweetest one is going to be the one that has the most concentrated one. So right when I tried the 3 cups, for me, the first cup was the one that tasted the most sweet. So cup 1 is the most sweet. Cup 3 was the least sweet. So if I want to put them from lowest to highest, so cup 3 is the least sweet, then cup 2, and then cup 1. If I look at the numbers, then let's see how the numbers work. So the smallest one here, 0.1 is the smallest. So cup 3 is the smallest. Then cup 2. Then the one with the highest concentration, 0.3 is the biggest of these 3 numbers of 0.1, 0.15, and 0.3. So here I'm going to put cup 1. So in terms of how does increasing the volume of the solvent, increasing the amount of water, what does it happen to this? What happens to the solution? Well, increasing the volume of water causes the solution to get less concentrated. Right? And that makes sense. So, right, if I add more water to something, right, there's more water and less of the thing that makes it sweet, right? There's less of the other thing. So, right, there's a higher amount of water that makes the solution taste less concentrated, less sweet. So if I add more water, I make the concentration decrease. I make it less sweet. So yeah, what we have then is that what happens is once we have more water, if you have more water, something is less concentrated. It's the same thing you do to your juice, right? If you have juice, you add more water to your juice becomes less sweet. Okay. So now we're going to do the third one. We're going to change both the mass and the volume, and we're going to see what happens. So in the first cup, we're going to have 15 grams. The second, we're going to put 30 grams. And the third one, we're going to put 45 grams. For volume, we're going to start with 50 milliliters in the first one, 100 milliliters in the second, and 150 milliliters in the third one. And we're going to see how their concentration changes. So let's see this. We're going to need 3 different cups again, 3 new cups. And this is what we're going to do. So the first one, we're going to add 15 grams. The second, we're going to add 30 grams. And the third one, we're going to add 45 grams. So let's turn this on, make sure that we have the correct masses. All right, click 0 here. All right, so the first one, we're going to add 15. That's a little too much. All right, 15 for the first one. The second one, we're going to add 30. Right, 30 to the second one. And then 45 to the third one. Then, to the first one, we're going to add different amounts of water. So we'll start by adding 50 milliliters of water to the first one. Milliliters of water to the first one. We'll add 100 milliliters of water to the second. And then we're going to add 150 to the third. 100. And then 50. Let's mix all 3 of them, make sure they're very well mixed. All right. So if we look at these closer, it's actually quite difficult to tell which one is the most red. So that's not going to, the color isn't going to really help us. So what we're going to do is we're going to look more at the calculations. So let's see what we have in terms of our calculations. So for the first one here, it says that we have 15 grams in 100 milliliters. So if we want to calculate the concentration, right, it's mass divided, the mass of the solute divided by the volume of the solvent. So we'll have 15 grams divided by 50 milliliters. So if we do 15 divided by 50, 50 divided by 50, we get that this is 0.3. The concentration is 0.3. For the second one, we're going to do 30 milliliters, 30 grams divided by 100 milliliters. So 30 divided by 100. And this will give us 0.3 as well. And then for the third one, we're going to have 45 grams divided by 150 milliliters. And so 45 divided by 150, we get also 0.3. Okay, so put these in order from the lowest to highest mass of fluid. So the one that has the lowest mass is cup 1. So cup 1 has the lowest. Cup 2 has the second most, and then cup 3 has the most, has the highest mass. What about for water? Well, it's the same thing here. So cup 1 has the least amount of water. Cup 2 has the second, and then cup 3 has the highest volume of water. What about in terms of their sweetness? So you can actually taste these. And it is very sweet. And if you taste all 3 of them, what you'll see is that they all taste the same. They'll have the same taste. So cup 1 tastes as sweet as cup 2. which also tastes as sweet as cup 3. They all taste the same. What about their concentration? Well, the concentration of the first one, of cup 1, is 0.3. The concentration of the second one is 0.3, and the concentration of the third one is 0.3. So all three have the same concentration. So the question then becomes, why isn't cup 3 the sweetest, even though it has the most Kool-Aid? So what this is to say is that, like, just because something has more, like sugar or more whatever it is, right, Kool-Aid or whatever it is, it doesn't necessarily mean that it has that it's the sweetest, because sweetness is not just sweetness does not just sweetness does not just depend on the amount of fluid. It also depends on the amount of water. So even though cup 3 has the most fluid, it also has the most water. Same with cup 1. Even though cup 1 has the least Kool-Aid, it also has the least amount of water, right? And so the idea here is that sweetness, right? Sweetness and concentration are the same thing. If something is sweeter, it is more concentrated. Sweetness and concentration are the same thing. So the taste that you have is based on the mass and the volume. You have to consider both of them, right? So even though this one has more sugar, because it also has more water, right? 45 divided by 150 is still 0.3. And then this one here, right? 15 divided by 50 is also 0.3, and 30 divided by 100 is also 0.3. So even though the mass of the third cup is the highest, the volume of the third cup is also the highest. And this ratio happens to be the same. So even though, right, this cup has the most water, and the most, right, and the most Kool-Aid, right, it's not going to be the sweetest because, right, because of that exact thing. So, right, if you have more sugar or more Kool-Aid and also more water, right, that's going to balance out. It's going to balance out the difference. So it depends on two things. It depends on the amount of water and the amount of Kool-Aid. You have to think of both of those. And that is where we end for this one. Great job, students.